Hello everyone, welcome back to my channel. Today we'll be solving the question number 3627. Find all the lonely nodes. So as you can see, it's a tree problem. Let's see what is asked in this question. So this question basically is asking us to find the lonely nodes. So how they have defined the lonely node? Let me explain here. So let's suppose this is our tree. So 1, 2, 3, and then this empty node, and then we have 4. So whatever the node who's not having any sibling is considered as a lonely node. So that's what it is showing as a result for that one. Let's take one more example. So here is 7, 1, 4, 6 empty node, then we have 5, 3, then we have empty node, we have empty node, and then we have 2. So we can see here this one is not having any sibling, this one is having a sibling, this one is also having a sibling, which is 5. 2 is not having any sibling, so 2 is one of the solution and 6 is one of the solution. So it will be 6 and 2, and in this particular case it's 4. So now we can understand what is a lonely node. So whichever node is not having a sibling is considered as a lonely node. Now let's see how we can solve this problem. Let's suppose let's first think how many possible cases are there when we are dealing with a tree. So there are not many cases. Let's say if tree has an empty node, or we can have a single node in the tree, or we can have 2 nodes in the tree, or in the 2 nodes we can have one on the left side, and we can have another 2 nodes where left is empty and right we have some node. Okay, so let's see. Okay, and other case will be when both left and right nodes are there. So these are possible cases. So in this particular case, if we want to find a lonely node, answer will be empty. In this case, left and right are empty, and so there will be no lonely node since one is parent itself. So in this case it will be not be treated as a lonely node, because by the definition only if the sibling, if only one, if the node is not having any sibling, then it's considered as a lonely node. So that's why it's not treated as a lonely node. Now let's see over this case. So it will be like this one, and it's not having any sibling. So in this case 2 will be treated as a lonely node. Now this particular scenario where this one is empty and we have a node over here, so this one will be treated as a lonely node. And in this particular scenario we have 1, 2, 3, and there is no lonely node over here, so it will be having an empty result. So these are all the scenarios. So from here itself we can formulate few conditions. So as you can see, if the node is null in that case, as well as when left and right nodes are null, so in those cases we just need to return null. So we have one of the condition ready with us. If the root is null, or root left is null, and root right is null, so in these 2 cases we just need to return back. So that is our first condition. let's analyze further this particular case and this particular case. We can say we have returning 2, which is an empty sibling. So in this case we can see left is having a, when we have a root, when we have a node which is having a only left element and no right element, no right node, in that scenario left will be considered as a lonely node. And in this particular case, when left there is no element on the left and on the right there is an element, so in that case when there is no element on the left, right element will be considered as a lonely node. So this is our 2 conditions. So when left, we can say over here in this particular case, from seeing this one, when right is null, then answer will become left. And third condition will be when left is null, then answer will become right. So these are our main 3 conditions around which we can solve our question. Let's try to solve this now, and then we will do a little run over there. So this particular one, let's write the code for that. So as we have understood, let's it's asking for this particular one a particular list of elements as a output. So let's create one list. Let's say list of integer, and we'll call it as answer. In this one we have just returned this particular one and declared it. Now let's write our main function which will call it and create our solution. So let's name our function as DFS. So since we are doing a DFS, depth first search, let's call it and pass our root element over there. And particular one, this particular, and we have to return the answer. And this particular case, whatever after iterating the DFS of that particular tree, we are returning the answer which is stored in our global answer. So that's what we are returning. Now let's write our recursive function DFS. Let's declare it. So we can write this particular function as this, and we can declare, since we will be passing the tree node over here, so we'll pass that particular parameter. Now the 3 conditions that we declared, let's write it. The first is where the root is null, or root left is null and root right is null. In this particular case, in both of these cases, we just need to return empty result. No result will be there. And the second condition was if the root dot left is null, in that scenario answer we need to add it in our list, which will be root right value. This third condition was when right is null, in that case we need to add the answer of the, we need to add the left element value in the answer. So these are the condition, and we just need to do a recursion over here for the left tree, and we'll do the recursion of the right tree, and this particular solves the question. Let me first run it, and then I'll explain for deep into it what is happening inside. Okay, so we have missed one semicolon, or two semicolons we have missed. One is here, one is here. Now let's run it. So it's saying DFS left error cannot find symbol, so it's not able to find the symbol. Okay, so here we have not given the root element itself. That's the issue here. So it's accepted. Now let's submit it. So it's getting submitted. Now let's understand what is happening in the code to do a deep dive to get a better understanding. Let's take this particular scenario itself, where this particular tree is there and how we are running our code. So this particular one will create a stack over here, and it will start, so our code will start from DFS of 1. From DFS of 1, D1 will be passed, which is the root node, and let's say answer is our array linked list. Here we have array list over here, which is declared, which is empty in the beginning. Now DFS1 will start. DFS1 it's checking the condition whether root is null, so root is not null, or root left and root right in this particular case are not null, because we are having values 2 and 3. So we will return nothing over here, and it will pass here, and we will check whether root left is null, so that is also not null, that is having some value. And now condition will check root right is null, so that is also not null, so it will pass this condition. Now it will go to root left, which is DFS of 2. DFS of 2 it will go, and it's one so it's a recursive call started. It's calling one method inside another method. So now DFS2 will check whether root is null. Yes, root is null, so DFS of 2 dot left will return, so it will not be put in the stack. Now we have DFS of 2 dot this particular case. Now what we are checking, since it's null, we have returned back. Now we are coming over this condition whether 2 dot left is null. Yes, root is null, so it will add the answer 4 in the array list, and it will go to DFS left and then DFS right. So since DFS of left is already null, so this will return, and DFS of right will be DFS of 4, dfs of 4 will be inserted here. So dfs of 4 will have left and right as null, so that will also return, and there is no effect on that answer. Now it will start. Now in this particular one, since we are called the dfs of 2, so dfs of 2, 2's left and 2's right are already done. So this work of this particular one is also done. So it will complete this particular execution, and dfs of 1 dot left is done. Now 1 dot right will start. So it will look something like, since dfs of 1 is already starting and it's already in the stack, we have 1 dot left execution done and 1 dot right execution will start, which is dfs of 3. dfs of 3 left and right are null, so if both are null it will return back. So this will also be cancelled out. This will also be cancelled out, and since this, so dfs of 1 left and 1 right is also done, so this will complete, and this particular dfs method will complete its execution, and at the end, so this particular one will complete execution and answer it will return, which is having the value of 4, and that's how it's running. So I hope you find this video insightful. If you find this video insightful, do like, share and subscribe. Thank you for watching.